Hello, this is Mr. Win, and this video is about polar coordinates. So far you've been graphing XY ordered pairs on the rectangular coordinate system, also called the Cartesian coordinate system. And that's where X was how far left or right from the origin, and Y was how far above or below the origin. We're going to use a different system now called the polar coordinate system. It's very similar. You need a starting point, the pole or the origin, and then you need two numbers. Instead of talking about how far left, right, up, down, you just need a single number called the directed distance, how far from their pole. Then you need to know the angle. If the distance is positive, you go that way. If you go negative, it's the other way. Here's some examples. Alright, the point in polar form where r is the radius and theta is the angle is 2 comma pi over 3. Alright, so this is 2 units from the pole on the angle pi over 3. It's right here. Notice this right here is pi over 3. And this is 2 spots, 2 units away from the origin. That's the distance of 2. That's how long our line segment is. Alright, here's another one. 3, negative pi over 6. So y'all know negative pi over 6 means going backwards down here. So here's negative pi over 6. We're going 3 whole units from the origin. So this to this is a line segment of 3 units. Then 3, 11 pi over 6. So from here we're going 11 pi over 6 units, all this. And then we're going 3 spots out. Notice these are the same thing. Alright, so in rectangular coordinates, each point xy was unique. That means there's only one way to get there. But that's not true for polar. We could have r theta, and then we have r comma theta plus 2 pi, which is the same point, just like that last example. Again, negative pi over 6 is the same thing as 11 pi over 6. Those are coterminal angles. Alright, you could also use negative distance, like I said earlier. So you could use negative r comma theta plus pi to get the same point. So here's the two forms. So here's showing multiples. So plot the point 3 comma negative 3 pi over 4. So we're going negative 3 pi over 4, so that's in quadrant 3, and we're going 3 spots out. That is the same as these 3 other things. They added 2 pi here, so that's saying is 3 comma 5 pi over 4. So from here you go 5 pi over 4, that's pi over 4, 3 pi over 5 pi over 4, and we're going 3 spots out, the same thing. It's the same thing as negative 3 comma negative 7 pi over 4. Negative 7 pi over 4 means going backwards to the first quadrant. Then while you're here at the pole, you're going backwards 3. So same place. Then negative 3 from pi over 4. So pi over 4 is up here in quadrant 1, but we're going backwards to negative 3. And there's just lots of ways to write this. Alright, the most important thing though is coordinate conversion. So to establish a relationship between polar and rectangular coordinates, let the polar axis coincide with the positive x-axis in the pole with origin, just like this picture. And because x comma y lies on a circle radius r, it follows we can do r squared equals x squared plus y squared. That's just the Pythagorean theorem. And if r is positive, you can use our basic things. The angle, tangent theta, is always y over x. That's normal. Cosine of theta is always going to be x over r. That's normal. And sine of theta is always y over r. Usually when we do the unit circle, r was 1, right? So sine of theta was just y, cosine of theta was just x. Alright, but here's what you use. Using these 3 right here, if you go from polar to rectangular, x is just r cosine of theta. And then y is just r sine theta, so multiplied. That's like breaking apart a vector. So here we have this directed vector. If you want the x part, you just multiply the cosine's angle to get the x part. And to get the y part, the height, you just multiply this whole thing by sine of this angle to the y part. And if you go backwards from rectangular to polar, you need to find the angle by doing tangent theta equals y over x. Then you gotta find the radius, r, by doing r squared equals x squared plus y squared. Alright, so let's practice polar to rectangular. Convert each of these. So in polar we have 2 comma pi. So from the picture we're going pi degrees, which is all the way over here, and I'm going 2 units out. It's right here. Notice this point is just negative 2, 0 if you look at our normal xy axis. So all they did was said x is just going to be r cosine theta. So that's going to be 2 times cosine of pi. Cosine pi is negative 1. 2 times negative 1 is negative 2. Then y is r sine theta. That's 2 times sine of pi. Sine of pi is 0. So 2 times 0 is 0. Alright, so negative 2 comma 0 in rectangular is the exact same thing as 2 comma pi in polar. Alright, root 3 comma pi over 6. So we're going angle pi over 6. So in the first quadrant, then going root 3 out this way. You do the same two formulas. Cosine pi over 6, you should know by using the unit circle, it's root 3 over 2. So root 3 times root 3 over 2 is 3 over 2. Then for y, root 3 times sine pi over 6, that's 1/2. Root 3 times 1/2 is root 3 over 2. So that's the rectangular coordinates. 3/2 comma root 3 over 2 is the same thing as root 3 comma pi over 6 in polar. All right, we're doing the reverse. So now we have rectangular going to polar. So -1, 1, you know, is left 1, up 1, this point. So I need to know what angle this is and how far away it is. So it's in the second quadrant. We're going to find the angle. Do tangent theta is y over x. Y divided by x is -1, so tangent theta is -1. You can arctan or inverse tan both sides, but that is a point on the unit circle you must memorize. That is 3 pi over 4. That's the angle. You don't need a calculator for that. Then we need to find r. So let's do r squared equals x over y squared. Put square both sides. So we get that, you get root 2. So one set of polar coordinates, and there's multiple ways to say this. Remember, you just do coterminal angles. For r comma theta is going to be root 2 comma 3 pi over 4, just like in this picture up here. So this is 3 pi over 4. Right, this is x and y, the same thing, so it's over 4s. And that's root 2 away from the origin, or the pole. All right, next one is 0, 2 is up here. We need the angle. The angle is pi over 2. That's the very top. And how far is from the pole? It's 2. So 0, 2 is the same thing as 2, pi over 2. That's just one set. One example, because it's coterminal angles again. All right, the last thing, equation conversion. So looking at the last two examples, notice to change one point to other point is pretty easy. If you go from polar to rectangular. If you do reverse, it takes a little more work. For equations, the opposite is true. It's easy to convert a rectangular equation to polar form. Just change x to r cosine theta and y to r sine theta. And if you have this quadratic equation, y equals x squared, you can change y to r sine theta, x to r cosine theta. You square this, then you divide both sides by r cos squared. You'll get r equals secant squared, secant theta, tan theta. But if you go backwards from polar to rectangular, that requires a lot of thinking. So here's example 5 that shows that. So describe the graph of each polar equation and find the corresponding rectangular equation. So here, a is r equals 2. The graph of the polar equation r equals 2 is just all the points are 2 units from the pole. It's this picture up here, figure 10.66. Notice the circle is everything that's 2 away from the origin. Alright, so since we know it's a circle, radius 2, we confirm this by converting to rectangular form. We use the fact that r squared equals x over y squared. So here's our original equation, r equals 2. You can square both sides, so r squared equals 2 squared. Then you replace r squared, the left side, with x squared plus y squared. And if you notice, this is the equation of a circle. All right, B, change theta equals pi over 3, polar equation, into rectangular form. Notice pi over 3 is all points on the line that makes an angle pi over 3 with the positive polar axis, just like a 10.67. So this angle is pi over 3. Any point on here is that same angle, pi over 3. So it's a line. All right, to convert this regular form, we use the idea that tangent theta is y over x. So we start with theta equals pi over 3. You're going to tangent both sides. Tangent theta equals tangent pi over 3. Tangent pi over 3 is the unit circle. Just use pi root 3. Then from here, you're going to change tangent theta, the left side, into y over x. So y over x equals root 3. Multiply both sides by x to get y equals root 3x. So that is this equation right here. Then last one, r equals secant theta. This one, if you graph it, you notice this is a up and down line. And we're going to convert it using this idea of r cosine theta equals x. So we start with r equals secant theta. Then you're going to multiply both sides by cosine theta. So r times cosine theta is r cos theta. Then secant theta times cosine theta, that cancels to 1. And then this left side, we know r cos theta is just x. So x equals 1, that's our graph. X equals 1 is the vertical line, undefined slope. That's the video. Make sure you ask questions in class. Thanks for watching. See you soon. Bye.